Hello and welcome to Programming in Python week 11. Today we are going to be talking about files, both reading and writing from the files. So first, let's just talk briefly about what exactly is a file. So a file is basically a collection of information that resides on your computer's hard drive, and they persist after your program stops, right? So they're written in memory that will persist even after your program is not working anymore. When a program's running, all your data is stored in what's called random access memory that gets erased and reused constantly by the computer as it's working. So a file is either stored in text or in binary format. And so there's different kinds of examples of files that we can use. The Python code that you write, the .py files, those are text files, right? They're human readable as you look at them. Web pages, .html, .css, right, are human readable if you look behind it. There's pieces of code embedded in, but as you look at the files, they are readable by humans. Binary files, on the other hand, if you were to open up and look inside at that data, it looked like gobbledygook. It would not be human readable. It is set up in such a way that the data is obscured so that only certain programs could read that data. So Word documents and images and music are set up as files that contain binary data. So when we're dealing with Python and we're dealing with files in Python, we sometimes want to read data in from files. So there might be a whole bunch of data that our program needs to have access to, and so it will read it in from a file. We can also write data to files. So if our program needs to save information from one program run to another, then we would write that data. We are starting with text files in our exploration into files with Python because they're easy to read and they're cross-platform, right? They'll work both on Windows machines and on Macs and Linux or whatever operating system your heart may desire. So why do we have these text files? So they're great for storing simple information, strings and ints that can be converted to strings, right? They're cross-platform and they're easy to use and are human readable. And things like text edit or Sublime, or even within PyCharm, there's tools to view and edit text files. So as we're doing this in Python, what we really want to do in order to access a file is we're going to create a connection between the Python program and the file itself. So there's a three-step process for doing this. Step one is opening the file for reading. And if you see that black line that I have between the .py and the .txt file, right? When we open up the file, we're making that pipe or that connection between our program and the text file. Once that connection is set up, then we can read data from the file. And once we're done, we will close the file. So in order to open a file, there is an open function that we are going to call. And so this built-in open function takes in two parameters to the function. So the first parameter is the file name. So that will be a string like words.text. That would be the file name that we want to open. And the mode, which in this case we're going to use R to specify that we are going to be reading from that file. So our two parameters, right? Open takes that file name and that mode, and this function returns an object of type file object. So this file object variable is its own type of thing. So like a string is a thing, an int is a thing, a list is a thing. File object is a thing that is that connection or that pipe between the code and the file itself. So we can call this is a variable, file underscore object. We could call this anything. So file in or just file, whatever you want to name it, right? That is your variable and it is of type file object. So that was step one, right? Opening the file. Step two is reading the data. So the most common way that we do this is that we would use a loop to loop through all the lines like a for loop. So in yellow, you will see a little box of code. So for line in file object, print line. So this, right, after our file was open, would go through the file itself, right? File object is that file object. And line then, right, in our for each loop, line becomes the variable that then, if we have a file with multiple lines, right, line is going to first be that first line, then the second line, then the third line, then the fourth line. So each time we go through the for loop, one entire line up until the \n will be kind of read in and temporarily be held within that line variable. Once we're done reading the data, maybe it's doing something as simple as printing it. Maybe we're going to be doing other things with that data, right? A for loop could have any kind of other calls within it. But once we are done, we need to close the file object variable. So this is very important. We said, right, there's that pipe between our .py file and our .txt file. So this pipe, or this connection between these two, if we don't call the close method, right, there could be corruption of that file if we leave it open. So we always want to make sure that when we're done, whatever we named our variable, I happen to name mine file_obj object, I'm going to call close on it to make sure that that connection is severed, right, and that text is free to do its own thing. So let's look at a full kind of code example here. So in my full code example, here is my text file. So this would be words.txt. And we'll see when you were working on this in your lab this week, or just in code with your professors, that this will be just in the same folder as your code, because we don't want to have to worry about which folder things are in. So we're going to stick the text files in the same folder as our code. So our first step is always number one, right? We're going to make that object. Here I called it fin by calling the open function, parameter 1, name of the file, parameter 2, the mode for reading from the file. Then we're going to read the data. In this case, I'm just printing each line of the data as I go. And then my third step would be that I would close. So if we see this, if we ran this code in PyCharm, what you would see on the console is something like is on the right here. And you might notice that's not quite what I thought would happen, because there was not extra spaces between this and the text file. But over here, I do have these empty spaces. So this is because in the file itself, there are these invisible new line characters at the end of each of those lines. So when we call print, Tommy Trojan has a new line, and then the print itself does a new line. And that's why we end up with these two that we go. So instead of doing that, what we can do is we can call line.strip. So remember, or reminder, either way, remember and reminder, we've seen the strip function before, right? That's one of the methods or functions within the string class. And all strings we can call myString.strip, and it would take away any white space from the beginning and end of the string, and then return that so we could reassign it to a new variable. So if I strip out the extra new lines, then when I go to print the line, then my output will look as I expect. So let's say you want to create a text file, or you have created a text file with names. So this text file, let's say, is called names.txt. So if I asked you to write a program to read in this text file, and then instead of just printing it like we did previously, what if I said, okay, all the names are going to be first name, space, last name. But when you output them, I want it to be last name, comma, first name. Could you write a program, given what we just did, to do that? I'm going to let you pause the video if you want and think about how that would look. Okay, welcome back. Maybe you paused me, maybe you didn't. Let's look at a program. So here is a simple program that would do what we just said. So again, we follow our 3 steps. Step 1, we open up the file. I told you it was called names.txt in read mode. Step 2, we are going to loop through each line in our file object. And we can call the strip, right, to get rid of white space. And then, do you guys remember split? Taking a string and breaking it into parts, right? We can break data into parts. So if I call .split, I'm saying, right, space is what I'm splitting on. And then I can use my list functions to say, oh, name of 0, the first part of the name list, that's the first name. Name of 1, that would be the last name. So then I could print last name, comma, first name. And I should get the output that we showed on the previous slide, Folt, comma, Carol, tire biter, comma, George, Trojan, comma, Tommy. Okay, so exciting text file stuff. What else can we do? So data can also be exported into different formats. So text files, super common. Another super common form of file is the comma separated values file. In fact, so common, it has its own acronym, the CSV files. And CSV files are used a lot in spreadsheet software. So Google Sheets, Microsoft Excel, if you made a whole spreadsheet, you would always have an option to choose save as, and you could save as a .csv. I'm going to let you preview something else that you don't even do in Python yet, but you can also in Google Sheets save as a TSV, which stands for tabbed separated files. And sometimes when I'm working with files, I prefer tabbed separated ones because commas are often in my data. And so it can get a little bit confusing, but we won't give you confusing files in 115. So you can use comma separated, which both programs do. So if we think of a simple spreadsheet like the one showed on this chart, so each row basically represents one line in the table from your kind of spreadsheet. So if you view this as your spreadsheet, we have the column headers, first name, last name, favorite ice cream, and then each thing after that is one row. So if we're looking at this, right, basically from the data itself, that first line, right, in a CSV file, we would get that first line down, and then the next line, and then the next line, and then the next line. So each of these, right, if this was then called data.csv, right, I could take my Excel or Google Sheet, save it as data.csv, and then my code could process the CSV file just like it did the regular text files that we just saw. So when we're processing CSVs, we're going to do the same kind of thing. We're going to open the file, read line by line, and then we can use the split function like I already did in our previous example, but now we could split based on comma. And when we split based on that comma, we'll be separating basically each of those columns from our text input. So, right, whatever line that we're going to be getting, the string that we want to split, and then that would return that list of all the different strings that were split by the file. And then, of course, we always want to close the file when we're done with it. So quick code example, we can take data.csv made from our favorite spreadsheet program. We can have some code.py that goes through each line in the CSV file, strips it, splits it, and then prints the list. And my output would be something like you see in the console window at the bottom here, where each line of my output, I would be printing the list with that data. What you might notice, though, is that very first line is really not the data that we want to process, right? That first line is our header. So most CSV files, or many CSV files, have a header row that's really labeling what's going to be in each column. So sometimes what we want to do is we want to call just read line instead of doing the for loop to go through all the lines, but read one line first to kind of get the header. So what this would look like, right, is I could do the line that's kind of starred is read one line, put that into header line. And now for each next line in the file, right, so for each line in my file object fin, I'm going to strip the line, I'm going to split the line, and then I can get the data list. And so we'll often see a pattern like this where header line, and then we go through our data one by one. And then whether we're printing it or accessing the different pieces with our list indexes, we can do that. So let's look at one more CSV example. So if I had a Excel spreadsheet like the one up at the top where we have kind of departments, course numbers, what semester that course is, and then number of students, right? We could save that spreadsheet as a .csv file, and we would see something like what's on the bottom with all the different data. And then if we were doing a program here, the CSV file would have all the data in it that would be at the same level as our Python program. We could have our program to read in that CSV file, but then our program itself is going to need to convert the data into the correct type. So everything gets read in as strings. So if we think about these pieces at data list of 1 and data list of 2, we're going to want to use that int function to turn those strings back into numbers if we need to do number things with them. And then finally, we get our full program here. So we're going to go through all the steps. So step 1, right, we're reading the file object, opening that CSV file in read mode. Then we kind of have our optional skipping of the header row by just reading in one line. And then step 2, we're going to go through every other line, however many lines there are in that file object. And first, we're going to strip any extra white space. Then we're going to split the data based on the comma. And then we can use our list indices to grab each column of data. So column 0 was the department. Column 1 was the course number, which we need to change into an int. Column 2 was the semester. Column 3 was the number of students. And then if we wanted to print the number of students, we could also print it out. And there you see our final version. So thanks for learning about reading from files with me today.